Hey everyone, hope we're all doing good. Hey George, you're not here? I'm not here either. Oh, why is my hair it's annoying me? It's all like wispy because it wants to curl, but it's too short. Really? It's gonna be a hair stream. I'm no longer a math streamer, I'm just a hair streamer. I wish it would just stay in place, but oh well. Let's see what's in our DMs. Okay, this person using the rational root theorem. They just said thanks for my explanation, so we'll dig more into that than we have to. Okay, I just want to make sure my Microsoft because I forgot to look at my levels. Then system of equations. I just linked them to a page because they didn't really post the actual problem, so they said thanks. All right, let's look for new math questions. I already regret wearing a long sleeve shirt. It just is randomly going to be 90 degrees today, tomorrow, and the next day, and I kind of hate it. Fahrenheit, 90 degrees. Thankfully, it's not Celsius 90 degrees. Ugh, sleeves are getting rolled up. Okay. It has one comment. I'll just see what the comment is. Oh, I don't actually see it. Really? You know, here I would do inverse sine of 1, which is pi over 2, and then you divide by 3 to get pi over 6. They're being taught it in a different way, though. Which this way also works, I think, because they end up with this result. So you still divide by 3, and you end up with a pi over 6, but is the plus 2 pi factor still appropriate? I want to make sure, because if pi over 6 is a solution, then you have every plus 2 pi like revolution is also a solution, but you do have another solution that inverse sine doesn't get you directly, because sine is equal to 1 at 2 spots, but inverse sine of 1 is only equal to one thing. So let me just, I want to just manually look at this formula and make sure that it works. I don't see a reason why it shouldn't, but let's just make sure. I'm not going to bother shrinking it anymore. Equal to pi over 2 plus 2 pi n, where n belongs to integers, technically. Let's divide by 3, as I said. We get pi over 6 plus 2 pi over 3n. And so I just want to check it for a few values of n to make sure that it does make sense. We'd expect it to work for pi over 6, and then whatever pi over 6 plus pi over 2 is, 5 pi over 6? Or no, 2 pi. Let's just bring up a unit circle. Let's not guess at this. One second. Images. 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 Sorry, working on it. This frickin' browser, man. So for n equals 0, this obviously works. We just get pi over 6. I shouldn't say obviously. I always say how much I hate the word obviously. If n equals 1, you do get 5 pi over 6, which is what I thought it would be. And 5 pi over 6. I don't need to expand the window more because we had to go over here. Wait. Oh, yes, because 5 pi over 6. But then you do, when you actually plug it back into the original equation with sine of 3 theta, it's 3 times 5 pi over 6. So you get 5 pi over 2, which is, hey Jed, how's it going? 5 pi over 2 at the top of the unit circle here, pi over 2 plus just 1 revolution of 2 pi. Okay. And actually, oh wait, so yeah, and you know what I was saying before is actually slightly wrong, because sine is only equal to 1 at one spot. And I was saying that that's actually kind of a unique case. If we had like an angle like just the pi over 6, which is what I was getting mixed up with, sine is equal to 1/2 at pi over 6, but it would also be 1/2 at 5 pi over 6. But here we're just concerned about equal to 1, so this is actually completely fine. For -1, I think it would still work. I don't think we have to check it that. Let's just let Wolfram Alpha check it. Sine of 3 times pi over 6 minus 2 pi over 3, which is what we get if we plug in -1. I'm doing way overkill for this problem. I'm pretty sure you just divide by 3 and that's your answer, but you know, it won't be me if I don't do overkill. 2 pi over 3 is 1. 4 pi over 3 plug in 2 is still 1. Okay, good. So yeah, I'm willing to believe this. All that to say. Just refresh. 2 days ago, no one answered this? Wow. Surprising. For theta, is to divide each side by 3. Get theta equals pi over 6 plus 2 pi n over 3. That looks weird, but it is integer. The equation. Positive, negative, 0 values for n, and verifying if you wish. Sine of 3 theta equals 1. The only trick to watch out for is these problems often restrict the domain, only ask for solutions between 0 and 2 pi. Oop, that's not pi. I keep on doing that, pi over 6. Since any other values of n will give a theta outside the domain. Okay, I think that's everything that needs to be said. So it's just an automata response. Let me actually erase the board. And the percentage of something that exceeds 3 centimeters using normal distribution if the mean is 1.8. Pi over 6? What about pi over 6? That Did I make a typo in the last one? Did I not write 5 pi over 6? Oh no, the 5 pi over 6 was me trying a value for n. Um, like with what, actually, I mean, I'll use this down here. I plugged in 1 for n just to verify that this formula does work. But the general formula is 2 pi n over 3. Oh wait, oh the 5, oh that's 5 pi over 6 from earlier. Sorry. I get it. Oh shoot, you're talking about the n thing that I said. I'm sorry. If you plug in 1, it should be, wait. Oh wait, you might be right, Jed, because you get multiplied by 3. Excuse me. Okay. Sorry, my watch just made a sound. You're right, because it's multiplied by 3, so we actually would have more than one solution over the 0, 2 pi interval. Oops. I completely, yeah. Thank you for catching that. So you'd only give pi over 6 n equals 0. Oh, because we need to check n equals 2 as well then. If n equals 1, we do get 5 pi over 6. Because it gets multiplied by 3 after, but it's still a valid thing for theta. And then if n equals 2, 4 pi over 3, it's still less than 2 pi, so that should still be in... Well, I guess we should check it. 4 pi over 3 plus pi over 6. You're rereading it now? Okay. Sorry, I keep on rearranging things. Right, for all integers n. So we'd have to say integers, but other than that, n is unrestricted. Hey, Spurskin, I'm good. How about you? You're fine? That's good to hear. Pi over 6 plus 4 pi over 3. This becomes 8 pi over 6 plus pi over 6 is 9 pi over 6, which becomes 3 pi over 2, which is still less than pi over 2. 3 pi over 2 with n equals 2. Hey, Drew. And for n equals 3, that should certainly be outside the range. I mean, even they didn't even ask this much. This is already overkill what I'm saying this much, but this, you're confused again? That's not good. 2 pi times 2 over 3. I'll just be completely thorough with this. You do get 3 pi over 2. That is less than 2 pi, so it is inside the domain. That's the point, Jed, because it's periodic. There's infinitely many solutions to sine of 3 theta equals 1. It's just often restricted to be between 0 and 2 pi. But because the period of this is so much shorter, we still get multiple answers inside of that. It does 3 complete. Not periods, but what it repeats itself 3 times over the interval 0 to 2 pi. So we would expect 3 answers in the 0 to 2 pi interval. This is higher than 2 pi, so this is outside when we plug in n equals 3. Got a deadline on your programming task, probably have stream in the background. No worries. Appreciate you being here. Good luck with your programming. So yeah, it is a weird thing where the restriction that I gave is over the default, interval for sine, but this sine function has um, a shorter period or higher frequency, depending on how you want to think about it. Okay. This is just a basic Z, or I mean, I don't want to say basic, but don't use VPN, they are collecting all your data. I mean, it's a free VPN, I expect that, but I also literally stream everything that I do with this browser, so. Tor for hiding your location? Is that even? I don't know if you can even do that on Twitch. I don't know about it. My chat does have some questions like you. Um, I mean, yeah, sure, Drew, ask it. Did I get a chance to look into RES? I mean, what would I didn't look into it yesterday. I was too busy playing games like a child, but I could have looked into it on Tuesday, I guess, but I didn't. Like I'm still not sure preview window for my comments. Ooh, that might be nice. I actually should look into that. Advanced probability, Drew, huh? Go ahead and ask it. I don't know if I'll be able to do it though. Okay, I'm writing a note right now, Jet, for look into RES. Yeah, for this browser, all I do is use it for streaming, and you guys can all see everything I do with this browser anyway, so I don't care that much about my data on this browser at least. You leave a note on the Discord? Maybe you did. Lebesgue oh no, I think I learned about Lebesgue integrals like for a split second in one of my classes, and I don't remember anything about them. And the Dirichlet, I don't remember how you pronounce it. I've heard the name, but I don't remember anything about it. Is that the one? That's not the one where it goes from like it just is off and then it turns on, like it goes from 0 to 1. That's a different one, right? Is that actually probability? Oh, it's that one. It's equal to 0 for like rational numbers or 1 for an irrational number, and it apparently is possible to integrate it. Don't ask me how. I saw Lebesgue with a G. Might be also like with a Q though, or might be like might both be right. I'm just curious to see what it looks like, but those are two like pretty. Those are two things that I'm really not that familiar with. French names in English. That's fair. Yeah, no, there's no way I can do this. I don't know why I'm even looking at this. Is it a simple question? I like read it, but I was focusing more on the Lebesgue integral first. Oh, how far in total does the fly travel and the cyclist meet? Is that just 0? Is that a trick question? Because the cyclists have met, so the fly 8 doesn't have to travel at all between them. 0 is incorrect. maybe it's a sequence then where well, I mean, I was just looking for a trick question. I guess it does say in total. But I was gonna realize like how far does the fly travel and the cyclist meet? But the cyclist admit it doesn't. Ugh. All right, all right. I did look at Drew's question. I want to do the stats one because it's an actual homework problem, but we can look at that. Start 30 miles apart. Begin cycling towards each other at 15. Because you don't have to account for the travel time for. Okay, let's look. Cyclist 1, cyclist 2. What was it, 15 and 15? Yep. You want to see my approach? Let's see. I just see that Drew just like put a spoil in there, but let's see if I can actually get it. And the fly goes 30 miles per hour. So if everyone starts at the same time, wait, how far apart are they again? 30 miles? I assume the numbers are going to be nice here and you get some kind of like cancellation. The keyboard is faster than my handy. Yeah. So in 1 hour, the fly will travel the entire distance, but it's not going the entire distance, it's going to wherever cyclist 2 is. So when you have to figure out where these two meet, would it just be up the 45, or not, like at 45 minutes? Because the fly is going twice as fast as the cyclist. And in 45 minutes, what's 3/4 of 30? It's a fraction. Hey, Maxi. Yeah. So for the first time the fly will meet cyclist 2, I think is just going to be at 30 times 3/4 miles. And that's going to be, it's going to just be like, you're going to keep on multiplying by 3/4 or something. Wait, that does reduce, doesn't it? Can't talk. 15 over 2, 15 times 3 is 45. There we go. Ask him, thanks for the follow. Focus on your hints and create inequality. Oh, I'm sorry about the siren. Okay, sorry, just muted my mic for a second there. I'm just gonna do it my way. I mean your mic, so you didn't hear, but there's a fire truck that just. Yeah, they found me, the government. So I mean, if we want to be really like this to me, like just eyeballing it, like our first iteration will be 45 over 2 miles is how far the flight traveled for the first meet, and then the cyclists are, I guess, it's not going to be just 3/4. Maybe it'll be 3/4 times a half, like 3/8, because the other cyclist is also coming there. But you told them Don does meth. Yeah. Do you like math? Am I here? Ugh. Okay. So I guess if we were to make like an equation for cyclist one, I'll call cyclist one C1 equals just 15. I'll say T for time. C2 is minus 15T plus 30 because it starts at, or that person starts at the 30-mile mark and comes back. And then the fly I'll call F is just, well, that's not perfectly accurate, but we can just call it 30T. But it's going to flip back and forth. So the cyclists, they should meet at the 1 hour mark. Oh, really? Because they travel 15 miles in 1 hour, and so they've traveled 30 miles in total, and they're 30 miles apart. So this whole thing happens in 1 hour. And wait, would you actually? This part might not be right. If we just find where these two lines intersect, that should give us where the fly and the cyclist 2 meet for the first time. 45T equals 30. This T is actually in hours. I was doing, yeah, and that's okay. 30 over 45. Isn't that 2/3? So why is that different from... Oh, maybe that does make more sense. Oh, yeah, that does make more sense. So it's 2/3 of an hour where they meet. And then we need to see if the fly even has time to get to the other cyclist. I assume so. Oh. So the right answer is 30 miles? It's an infinite series to get... I see. Okay, I was wondering. I assumed that there would be an infinite series in there somewhere. But I guess either way, the... Well... Because I guess if we're saying the fly, like, goes the first 2/3 for the first one, and then the next one is gonna be like 1/3. I guess it's gonna... It's fine. It's 30 miles. You mean 1 hour? The 5 minutes at a constant speed. Oh, it's gonna... I see. That's the simple trick. I assumed that there's gonna be like a mental math way to do that, but I couldn't find it. Read out. Oh yeah, I didn't learn that much about von Neumann or von Neumann. I don't remember how my professors pronounced it, but because you're gonna try some of a series. Yeah, I was basically trying to work out like what the pattern for that series would be. Hey, eat the 2i pie, how's it going? Oh yeah, Maxi, that would make it more like obvious. That's a clever like way of showing how an infinite series of numbers can add to a finite number. I mean, you can type it, Jura, like usual, but I make no promises with you. Yeah, e to the 2i pi streams math too, so check them out. Um, you aspire to be on? I like that answer because like people ask me that too, and I don't know how to respond or how you define a mathematician, I guess. Okay, so what's up with this? Oh wait, we're looking at Jura's thing. Imagine an ant stays on one side of the rubber rope. The rope's length is 1 meter. Okay. Need a cough drop. The ant goes a centimeter per minute. Okay. That's a pretty slow ant, isn't it? I mean, I don't know if that's ants normally move, though. Doesn't seem that far up. Each minute, the rope is stretched by 1 meter. Okay. It seems like no. I guess the ant does make some progress where the rope gets stretched out the entire meter. So even though the rope is stretching, not all that stretch is going to set it back, maybe? Hmm. I'm wondering how you would set this up. I assume you can make 2 lines to represent the situation, but with the distance changing, it feels a little bit weird. I feel like there's no way that the ant is going fast enough. Because in the first minute, it only goes 10% of the way, and then the rope gets stretched out and basically doubles for the first one. And it may have gone 10% of the way, but now has 1.9 meters more to go, and it's still only going 1 centimeter. Okay, true. 1.8 meters maxi. Oh yeah, 10% rather than half. You're right. Yeah, Jed. I don't really know the answer to this. So if you want to, or I don't mind if we just make it a discussion because I'm not really sure where to go with this problem. All good, Maxi. I was pretty proud that I did that 1.9 meter conversion thing correctly, even if I messed up um, doing the stretch of the rope right. Maxi has no excuse, but I mean Maxi did the conversion right, just not the the stretch right. Okay, an ant stays on one side of the rope. Will the ant ever reach the other side of the rope? Oh. No, I assume that meant like three-dimensional, like the ant doesn't like rotate around. Like it's not doing a spiral, it's moving in a straight line along the rope. That's how I interpreted that. Oh wait, or is it really just the ant is as the ant is being stretched along, it moves at a centimeter per minute? Well, no, that'd still be a meter. And it's not the movement of the ant being set back, is it, Druha? Well, actually, the ant must be speeding up. If it's a constant speed of 1 centimeter per minute, the ant must be speeding up to counteract the stretch of the rope, wouldn't it? Or maybe not speeding up. I don't know. This is because you pick it up and move it. Yeah, to hell with this math problem. But if the ant's net speed is 1 centimeter per second, that maybe it's not speeding up. That would take into account the stretch of the rope. So the ant is still making progress because it's just going, I guess maybe 1.1 or 1.1 meters per second to counteract the stretch of the rope, and the net speed is only 1 centimeter per minute. I'm getting my units wrong, but so maybe the ant would, if we're careful about the phrasing of the question, because so we have a rope here, an ant there. That's how ants look, trust me. The ant, which is on the rope, is being pushed back by the stretch at 1 meter per minute. So in order for it to have a net forward speed of 1 centimeter per minute, I think in total, or I mean, I think that means, if the rope wasn't stretching, the ant would be moving at 1.1 meter per minute. Because if we're given that the net speed is 1 centimeter, maybe is that the logic? And so it would still reach the end of the rope because we know it's making progress. Maybe I'm not in the spirit of what the question is actually asking, though. Well, I think of a rope that's made of whatever thick fiber, rather. But you said a rubber rope. So if you pull on each end, oh, maybe you're responding to Jed with that. So Jed, I think it stretches out from the middle, and not all the whatever stretches behind the ant is irrelevant. I don't know what's happening. To one end, the origins, the ant moves with the stretch. That's if the rope is anchored on the wall, and you're pulling it away, so the stretch is only in one direction, right? For what you're saying, it eats a toy pie. I don't know. I feel like this. I feel like there's multiple ways to interpret this. Or maybe I'm overthinking it. The rope is stretching in a different dimension, then you're not pulling on each end, you're grabbing the top and bottom and stretching it almost to make a piece of paper. I feel like that wouldn't be the answer, but I feel like we're all overthinking this question. Essentially, the rope snaps and the ant dies. Yeah. Some kid comes up with a magnifying glass and fries the ant. Well, yeah, Drew is not overthinking because you know the answer, but the rest of us, I think, are like, we all have our own interpretations. So, I mean, I don't know. I kind of want to do the stats question I've been staring at. I do think my interpretation is wrong, though, that I had on the thing. Um, so I don't know about the ant problem. I do want to figure out the stats question. I don't think it's gonna be that bad. Exceeds 3 centimeters. Forget about the rope we stretched, Jed. What is his tensile strength? Yeah. And is Jed stretch from the center forward or? Okay, so I guess for the stats problem, let's find the z-score. It's the sample value 3 minus the assumed mean 1.8 over the standard deviation of 0.5. This is mental math. 1.2 times 2 is 2.4. Now we go to Z calculator. Or just the table. Yeah, no, I gave up. Let's find a Z table. Excuse me? Did Jeff Bezos buy my browser? Why would you bring me to Amazon? Why? Stop. Why? How is this Amazon? What the heck? That's weird. I hate that. This freaking browser. It's a shortcut to search Amazon? Okay. The VPN, apparently. Who do you have to pay to get that shortcut? Oh my god, I never knew that was a thing. Um, Once every minute, that does make it a bit easier, so it's not, you don't have to worry like it being continuous, I think. Or I think it makes it easier at least. Um, 2.4 is 0.9918. If we do, we want greater than 3 centimeters, so we need to do 1 minus that, because the Z table goes up 2, but we want more than. So we expect 0.0082. Let me just make sure. Okay, yeah, 9918. That's what I put. Let's do that. Okay, and so they get, or 0.82% is right, yeah. Because I got 0.082, but you can move that to a percent. Open settings. Oh, okay. Let me bring up my settings. Settings slash, oh, okay. It makes life easier. I found it. Wait, why is for Yahoo D? Oh my God, no. Get rid of all these. Oh no. It doesn't let you get rid of them. Uh, like I can only make it default, but I can't actually get rid of it. It's annoying. I'll just put something in front of the Z, I guess. Or I'll just like add something else on. I mean, that's true for scan. I've never been like that into like um I guess securing my data like that, but I mean, this VPN is just like a filler until until it makes like financial sense to buy a VPN for this. Um, I only use this browser for streaming. I use Chrome and Firefox for everything else. So I don't really care if this browser gets its data harvested or stuff like that, because I'm not going to get that much. And it's all on stream anyway, so. The initial question asks for... I don't mind if you want to say it, Jura. If someone else is still working on it, then I guess it's up to you, but... Or exceeds 3 cm. Yeah, it seems like the breaking point is if the ant crosses the halfway mark before the rope stretches, which it doesn't seem like it would with that given speed, but I might be wrong. I don't want. I just like using Google. I feel like I know how to get the results that I want from Google. You don't think it's required, really? Or it might not be the halfway mark, like depending on. It does traverse a little bit, but maybe the quarter mark. I'm not sure, actually. The up to value. Do 1 minus that value if you want exceeds. Oh, maybe it's first scan. The ant will eventually get to the side root. So how does that work? GZ table. I see. Okay. That's annoying, but I guess I can do that. To feel like a tech god, tech god. I know the integral roots. I haven't heard of an integral root. Fuck cat? Okay. Oh, integer. That makes more sense, Maxi. Thank you. Oh, okay. That is funny because in the music video for that song, Eminem is like plugged into a computer. So they will travel 1/100th of the rope in the first minute, right? Right. This one we can just plug into Wolf. We can plug this into Wolfram. Harmonic series divided by 100. Oh, if whether it converges or not? Huh. That 1% is already traveled no matter how much you stretch it. Right. We're able to get that far. No, so this person, they said that they used the rational root theorem to try and find the roots of this, but I think their teacher is mean because they gave them a 7th degree polynomial that has no rational roots. So I like the username too. This polynomial, one irrational and 6 imaginary. 65 imaginary. Second of the ant travels 1/200. On the third 1/300. Oh yeah, so that is the harmonic series times, or divided by 100, I guess. So, but the harmonic series does not converge, but you said it would get to the other end. So how do you know it does for the harmonic series? Oh, you want it to diverge. Because if it converges, it's only going a set distance. Oh, that's funny. That's a clever problem. And so if it was like if the power of the series is greater than 1, it would converge and the ant would eventually there's a set distance the ant would get to, I guess. Or maybe I'm interpreting that too like badly, but I guess at a certain point I don't know if that ant I don't know. Blah, blah, blah. um I'm gonna stop talking. The method often called the rational theorem can only find rational roots. The polynomial has one rational and 6 imaginary roots. Found since I plugged the equation into alpha. basically, if you did all your math correctly and none of the possible values work, there are no rational roots or integer. I'll just work on the problems that I think that I can do. Here's a geometry. Oh God, I don't think I can do this problem. I don't really know what the question is. Can someone explain how to do this figure? I sure can't. Well, is this supposed to be like three-dimensional? Like, is this three squares like put in a triangle almost? I don't really know what this means or like what the goal is. Three perspectives of a shape. Yeah, I think these are Spanish words for like, I forget what arriba means. But I feel like it is like for like different directions or something. Actually, I guess they say in English. First one is the side, second one is the front, third one is from above. I don't know. I don't really get how you do the figure. Are you supposed to maybe draw on this? Like this is your grid that you draw the shape in? You fill the cube and slice it from top. Oh, it's just basically like three faces of a cube. That seems too simple to me. Might be right, but Drew thinks he has a strategy. Okay, I don't know. If you want to, I can link you, Jed, but I don't know with this. Look for an actual math problem that someone's, or like a homework help problem that hasn't been answered yet. Hmm. Oh God. It's like modulus Sudoku? Wait, does this mean 2 mod 1 equals 2 or 2 divided by 1 equals 2? I'm confused by what this means. Nine possible dots and 9 possible vectors. Oh, okay. This scares me. I'm not looking at it. That is an answer. This one does not have an answer. Is the centroid of an area like the center of gravity or center of mass? Okay, yeah, so that is the center mass. Oh, geez. Hey, Shep, I'm good. How about you? Thanks for liking the haircut, I guess. Still the same? Oh, I'm sorry. I guess we have our formulas here. I haven't really done this calculation myself before. We can see though. Plot y equals x cubed, y equals x, or 2 minus x. So let's see where these intersect. At 1. Okay, that makes sense. Oh, they've only done this with 2 curves. They only have 2 curves. Oh, really? That Z4 is countable. Huh. I guess it makes sense. Oh, you want to talk, Jed? Okay, let me bring it up again. Hey.
Hey.
Oh, wait.
Let me get this muted and get
You might
the
not be
share
able to hear
going
me.
here. Share the...
Can you hear me actually? Oh, you can.
I can hear you. Yes.
Okay, good.
Look at this. GeoGebra has a 3D modeler.
Oh, wow. Let me get this on stream. Okay.
By drawing a cube. And then I created a diagonal along the bottom and the sides going on the front face and the side face. And so so if I get rid of the cube, well, see, there's the cube. If I get rid of the cube, you get that shape. And if you look at it from this perspective, it's a diagonal line, similar to the
Right.
original question. If you go off the other axis, you get a diagonal line facing the other direction.
Okay.
And if you go from the top-down view, you also get that same shape. So your shape is basically that cube sliced from one corner to the bottom, from the top front corner to the bottom diagonal.
Okay, so that's what I was imagining.
Yeah.
I guess I
So
don't know what you do for the question though.
how do you approach it? I mean, I started with, okay, well, you got to have a shape that from one angle looks like this, right? If I can get it to line up right.
Or like,
It's kind
what's
of
the
hard.
question like asking for? I guess. Like, is that the answer? What you have there
Th-
right there?
This is what it was looking for, right? Can you explain how to do this figure? So I started with, okay, I've got a side that looks like that. So that looks like that, right? And then I've got a side that looks like that. So that's the second side of the cube. And then I've got a side that looks like that. So if I go back to the front and drop it down, it seems to match. And the way I just visualized it in my head, basically. I started with a cube, and I was like, okay, well, if I've got a cube, how can I create something? I need to have something that looks like this from the side. So I drew that diagonal. I need something that looks like, stop moving, like that. And then I have one from the other side that looks like that. And then I need one from the top. Well, if I look at the top and I don't have that bottom panel, then basically I just have two triangles, right? So I need to have something goes here. And then when you fill that in, you end up with that prism shape. Where did that? Oop.
Yeah, I mean, so I mean, this is a really cool tool, but like, I'm just confused on what the actual answer to the sentence was put on the paper for. Like that it's that shape, or like I supposed to.
Well, I mean, they give you a place to draw it. It looks like he's done some drawing on the previous thing. So
Oh,
he needs to
okay.
create how to draw a figure in this space that has this on one face, this on one face, and that as the top-down view.
Oh, okay. So that's like the three-dimensional cube that like has the grid, and they have to draw that like
Hmm.
basically cut in half diagonally.
Correct.
Okay.
So like you have to figure, okay, well that's the bottom left corner. This is the bottom back corner, and the bottom right corner is over here. So the line here doesn't actually exist. So you have to draw that in, and then draw a diagonal that goes up to the top here, and draw a diagonal that goes down to the bottom there, and somehow do that in a way that makes sense geometrically, because you can't draw a 3D model in 2D very well.
Yeah.
So I would probably just draw a line here, I draw a line here, and I draw a line across here. So basically it looks like a triangle from the front edge. You know, if you drew it like with that perspective where C and E are lined up, if I can get to that perspective, I don't know if I can, you end up with a shape that looks like, well, I guess you're drawing this as well.
I
But you got
guess
this little
that'd be a
dotted line in the back.
triangular pyramid,
It is a
basically,
triangular
or I
pyramid.
guess a right triangle, not a usual pyramid. I guess. Actually, no.
Well,
There depends on perspective.
it depends on perspective. If you were to flip
Yeah.
this whole thing around, so it was, and I don't know that I can flip it that way. Actually, I can. If I take the cube, I can move this cube point tools. Move. If I take this point here, and actually it's this point here, I have to move. You know, I can flip the shape around as I need to. So if I can find a way to flip it so the triangle's on the bottom, you do end up with a triangular pyramid.
Okay. Yeah. I'm trying to think how I would phrase this in text.
But
So
and this is a diagonal of 2 square root 10. This part right here, or this one right here, is also that same distance, and this is that same distance. So this is actually an equilateral triangle.
right, I think all the sides would be. Oh no, you're right. The
No,
other
because
three sides would
these are
be the
exactly
same,
10,
but not all
and then
six
these
would be the
are
same.
10 square root 2 or whatever.
Yeah. Okay. Yeah, that makes sense. And then we don't have dimensions, so that's
So
just
it's
like
not
how
a.
you treat them, right?
I'm sorry.
Even though we don't have the dimensions in the original problem, so it could be like
No,
something else too.
Yeah, it doesn't get it's just asking you to draw that. So this is like, I don't know, this is a geometry as much as maybe like a CAD kind of
Yeah.
thing. But I
Okay,
found out,
Central.
I learned that GeoGebra has a 3D modeler. So that's something new.
That is. Oh, that is cool. And sorry, I just switched to push talk to today, and I'm struggling with it. So if I'm being weird with how I'm talking, that's why.
That's all I had to share.
But all right, yeah, thank you. I guess I'll get back to that person.
If you wanted to. I mean, that's kind of how I approached it. Okay, you got a face that looks like this, so you're gonna have some line somehow that does, that number. And then same thing on the other side. Get the model to move around correctly. Let me bring the cube back in. It makes it a little bit more obvious. So I got one line there, and the top needs a line that goes from corner to corner. And then once I got those three lines in place, how can I make a solid out of it? And
Yeah.
that's the way that's this point base. It's basically, if this were triangle, I can't move it unfortunately. But if E were A, you'd be just having a triangle. But when you take A and just move it up to E, then you get that 3D shape,
Okay.
right? So, and that gives you the front and side faces to work properly.
Okay. That's cool. The site
That's all
does
I got.
everything, it seems like.
It does quite a little bit. Anyways, that's all I had.
Okay. Well, thank you. All right, bye. Okay. Little show and tell from Jed there. Central, hope you're doing good. I literally like so sorry for the window sounds that we're playing. I just set up push to talk in Discord because yesterday I was playing Central. I kept on, or like every time I play, I'm in Discord. I mess up like my muting and unmuting. But I put my push to talk on numpad period, but it's also delete. And Windows thought I was trying to delete things, I guess. So I'm gonna find a new key for my push to talk, I guess. I don't know about loves, but oh, George, the quadratic formula. It's the minus b plus or minus 2a, or I said that wrong, but it's this thing right here. Use it to solve an equation with like x squared equal to 0. Shit. Don't tempt Central, he'll do it. But yeah, Georgia, if you just Google it, you can see the formula for yourself too, but if that's what it is. Red alert. Yeah. Ugh. Did you not play
Oh
today's Central?
my.
Oh my. Just running through them all. Oh wait, no one did first.
Always remember,
Central got it.
if you ain't first, you're last.
That first one is once per stream, and no one did it this one. It was just there for the grabs, and it took an hour and 20 minutes. Yeah, 33,000. That's probably one of the most points that someone has. I need to remember because Spectre has a good few. I bet that Jed has a good amount too. You're busy doing that. That's fair, Jed. 75,000. Yeah, it needs a bit long overdue to add uses for channel points. I need to do more. Fuck you all, I win. Sounds forgotten. But the other three are on a 10-minute cooldown, so it's gonna be at least 10 minutes before we can do another one. Okay, how am I gonna say this? 75, 420, blades. You can keep doing them. That's why I put it on a 10-minute cooldown, because I'm afraid, when someone spams it. Uh, Maybe I should get a 420 sound. I need to figure out a movie quote or something, though. This question... Wait, how do we define from above in this? Like, this feels like I don't know. So look at this. Like, if this is from above, wouldn't it be like almost like the roof of a house? But I guess depending on the perspective with that, it could look like that. You forgot what you were gonna ask me? Okay. Um, I think I stayed up too late last night because I can't even think of how to phrase this right now. That's Saturday. I don't think I have anything planned right now, but I just have to see how I feel. So I guess maybe. It'll be math, but after that, I'm not sure. I still need to get a factorial stream at some point this week. Okay. Okay, you know, I can't think of a good way to phrase this. So, if Jed, if you want to respond to this one or something, then feel free. But I'm not gonna, because I just can't come up with a good phrasing for it right now. Um. So I think with this one, I don't need to go through and do the actual calculations. Yeah, Jed, exactly. It's like I don't know how best to like help the person there. Uh, I think this person though is getting confused with the y equals 0 being like a third curve, but they don't actually have to worry about it. The main ones to focus on are y equals x cubed and x plus y equals 2. The y equals 0 is just the y-axis. Basically, will be the lower bound for your integral. We'll go up to x equals 2, or x equals 1, upper bound, since that's where they intersect. That's where the first two intersect. Of how these are done, this page, a useful explanation or helpful explanation. Okay, I think that's enough. Not go overboard with saying things that I don't have to say. Okay. Integral arc length. Not sure how to start this. Come on. Arc length usually isn't too bad. Oh my god, this browser is really slow. The curves graphed below are all examples of continuous functions f that have the properties f of 0 equals 0 and f of 1 equals 0. F of x is greater than or equal to 0 for 0 is less than or equal to x is less than or equal to 1, and the area under the graph of f for x equal to x equal 1 is equal to 1. Okay. From formulas for the three functions satisfy all the conditions above. A science stream? Is that just me being confused? I guess that's my math streams too, to be fair, but... Oh, that's an interesting problem. This is like an asymmetric parabola for the third one. I don't know what function that would be. It's like a little warped to the right. I guess like skewed. It must be a rational function, I think. With a horizontal or with a diagonal asymptote and a vertical asymptote. I think. I remember old science. I guess trying to answer science questions, but I remember almost nothing. I mm, I wonder what advice I can give for this person. Because this is kind of a fun question where you need to optimize this for arc length. I wonder if there's a way to do this and know that you're right, that you have the optimal solution. Because we don't really know, I guess, but like one of these first two is a parabola. Another one, I assume, is maybe a quartic or even a cubic or some higher order polynomial. I assume this is a rational function, and this fourth one is just some kind of piecewise function. I'm not really sure how you would get that. Why couldn't you just have a straight horizontal line? That's continuous, technically. I guess that's just another kind of function you're asked to investigate, though. You have to do like three separate linear functions. Talk about fermentation. I could talk about coffee for fermentation, but even then, I don't really know much about it. I don't know if I can really help with this one. Well, actually, at least for getting a parabola. Is that about philosophy? I don't know about really about philosophy either. Well, okay, let me. I keep on closing out of it when I don't mean to. Philosophy is like Aristotle, or like just like thinkers. I don't know how that word translates, but like, or Descartes, Nietzsche. I'm sure there's a famous one that I'm missing. It's a joke? Oh, okay. I'm sorry. I'm slow. I assumed it was a translation issue. Their names are tricky in English? Oh, okay. you could set up, you know, from the given information, and the parabola have to have roots x equals 0 and x equals 0 comma -1. Which philosophy concept is closest to yours? I don't really know enough about philosophy to even say that. Hmm. I don't know. I guess I don't know like if there is philosopher that matches this, but like maybe like optimistic nihilism, if that makes sense. Like I don't really care to think about things that don't affect my daily life a lot of times, and you know just kind of worry about what's in front of you first, I guess. But not in a negative way where it's like not to say nothing matters, but I guess, or if nothing does matter, then make the most of your time here. I don't know. I'm explaining it poorly, but this is kind of generally how I think about things. You're going home on Friday, Shep? Oh, that's great news. Like, it's like, I don't know. To me, it's part of like nihilism, NHILISIM, is the idea that like nothing we do on this earth matters, so why bother? And like, I kind of agree with that, but I don't agree with the conclusion. Like, if nothing matters, then why not have a good time, I guess? I don't know. I'm not very good at philosophy. And even then, there could be some reason that it matters, but I just don't think that I'm gonna be the person who figures it out. Is arc length L defined as distance from of the line measured from end to end? Yeah. There's a formula to do with integrals, which I assume they're supposed to do. And they're given estimates for these. So they could kind of try a few different types of functions and see which ones get close. But yeah, so I don't know if there's a philosopher that like matches that idea, but I guess that's kind of how I tend to think about things. Have the form f of x equals a x x plus 1. Very interesting view. Yeah, I mean, even that, I don't tend to think about my view of the world that much, so I have a hard time like phrasing it, but I don't know. I just think of it as like no one knows what happens after you die. No one knows if there's like a grander purpose, or you can believe. But I don't think anyone, you know, you can never truly know. That's why you have to have faith, to have religion. Or I guess that's what faith is, that you don't know but you believe. So I mean, I just try to help other people like do what they want to do in this life, and whatever's after that, who knows? Absurdism? Oh, really? Is that a burn, or is it, or is that a real thing? Let's Google it. Irrational meaningless. Oh, it is a real thing. The search for order brings the individual into conflict with the universe. Yeah. I guess that could be positive or it could be negative. I definitely try to take a positive view on it, but if the root is -1, the formula for the parabola is +1. Because when you set the x plus 1 equal to 0, you get x equal -1. The a could be positive. I mean, we know the a will has to be negative. But you don't have to put the negative sign in front if you don't want to. Oh, Thank you, Jed. I get the sign flipping wrong. Well, okay. It's just the sign flipping I got mixed up on. You're completely right, Jed. Well, like always, I shouldn't be surprised. I shouldn't question you. Uh, um, you could take the integral of that from 0 to 1 and set it equal to 1 to find what a must be. I know you can have a horizontal parabola, but you can have like a diagonal parabola too? I guess I don't see why not. Um, you're right, Jed, but it does have to meet the criteria that the integral equals 1. So a can with a parabola, a can only be a one number. You could try different degree polynomials, but you're stuck with this form. Calculate, then calculate the arc length and see if it matches any of the given ones. Look at the third example. So I assume this is a rational function, because as far as I know, it's the only way you can get a skewed one like this. Like, this isn't a tilted parabola, I don't think, because it doesn't look symmetric to me. We can make it bigger. Oh, that's not bigger. Yeah, so I think that this is a rational function with a vertical asymptote somewhere over here and a diagonal asymptote somewhere over here. It's just barely not symmetric, though. I agree, Jed. What's the rule for higher degree polynomials and whether they bounce on a 0 or cross a 0? Is it an even power? I think this is like a pre-calc thing that I learned that I can't quite remember. I think f of x has to be defined in parts for that last one. The other ones, I guess you also could. So like, I guess for this one, you could define in like at one half of the function, one half of the other function. It gets kind of complicated though. I want to play around with Wolfram Alpha a bit. So we have like x squared, x minus 1. That's going to cross at 0, or no, it's going to bounce at 0 and cross at 1. If we square them both, it's going to bounce both. Okay. So they need to both be odd to get the behavior that we have. I should slam a minus sign in front of these. That's a crazy looking function. That definitely doesn't match what we've had though. We have a cubic that matches this though, so maybe I'm not doing this. I might not be thinking about this right. There should be a cubic. Oh, actually, I guess there wouldn't be a cube. Yes, you can have a cubic that matches. You wouldn't do another power though. You'd have to do like x minus 2 or something like that. And not a minus sign. Something like that. What are you saying, Jed? Could f of x be defined in first? F of x equals 1 for 0 less than x less than 1. You're right, Jed. I had that same thought with that piecewise, it's like the flat line. But I assume you have to match it to this form of a function. So you can't just do a flat horizontal line because that you still need diagonal lines on either side. I think, like we're just not considering the horizontal line case. I mean horizontal only at least. Shortest L will be a symmetric curve. Height and fatness, yeah. Yeah, you could do a sine function too. A sine function might be worth investigating too. Actually, they just asked 3 functions in general. Wait. Oh. Well, for probably, or I guess an polynomial, just your value for a. That's the thickness. Well, I guess that's more the height. I mean, no, I guess the fatter, there must be a better word for it, but the fatness of the curve is kind of fixed with 0 to 1. You can make it taller or shorter. So actually, I think they just want 3 functions in general. It does not have to match these 3, as far as I can tell. These 4 are just examples. Draw the problem on my board. Okay. Have to be exactly okay. 1, something like that. Tangent line, I assume anywhere. That's a wow. What a horrible tangent line. But I mean, just made it worse. I do math. I don't do art. That's to the maximum. Oh, that's just a horizontal line, right? Right. And draw another curve that is smaller than the current one. Okay. Right, so it would have to go out wider. I should have done a different color. Oops. Wait, with the same tangent? I think like the same like tangent at the maximum. How do I make it? Oh, you. If it has the same maximum and the same zeros, I can't draw a different curve. An inverted V? Let me. Like with straight lines. Okay. I drew that horribly again, but who cares? It's like basically a negative absolute value function that's been shifted. Okay. I forgot to do a different color again. So you're right, but we don't necessarily know that these maxima are going. Actually, these maxima almost certainly can't Actually, no, they literally can't coincide. If the area under them is going to be 1, the negative absolute value has to be a bit taller because the parabola just has more area included in it. So we are constrained with the area under it being 1. Oh, okay. That's what you're saying. Once you have to move the height to account for the thinness of the curve to make the areas the same. We could calculate it for these two functions. I don't know if we can calculate that generally, or we almost certainly can't. How much of between how quickly the curve reaches the maximum and how high that maximum is. I mean, I guess you're describing a second derivative. Or even the first derivative, I guess. Oh, maybe that's where you're going with this, where the parabola has... Like, the straight line just has a constant rate of change. The parabola has a variable rate of change. Okay, x squared and x to the 4th. Might see where you're going with this. I mean, you say fatness, I say height, I guess, but so I think it really is just the like it does influence um how fat it is, but it is still constrained by the roots being 0 and 1. Okay, so yeah. So like the quartic is obviously it's more like flat on the bottom and then it comes up, whereas the parabola just more directly goes up. And so that does mean that you can have a lower maximum. No, the quartic can be flatter, I think. Something. Words, smartness. Um, the quartic can be closer to the x-axis because it has a flatter top. Or like it includes more area in the same 0 to 1 interval. Okay, that makes sense, Jed. Can we get a quartic that's... So what I was just playing around was like with... If we have a quartic like this, though, I mean, we can flip it. Can we get a quartic? Because like this doesn't behave how we want it to, because it flattens out on the ends, and we want it to go directly down into 0, 1. So could we maybe do like maybe not powers of the roots, but different roots entirely? So like we had x plus 1 and maybe x minus 2 at a root onto either end. Yeah. So I guess something like that would achieve what we want. And you still put an a in front of it. But the roots, I think you just have to guess and check. You can look for trends in how you increase or decrease your roots here. And I guess you don't necessarily have to put one on either end either. You have to do a lot of experimentation for a quartic. And even then, if you're going to do this little experimentation, like why not look into higher degrees too? So, I mean, there's a lot that you can look into with this, I guess. Let me see. Okay. This question, open-ended. Would a fatter curve have a longer arc length than a thinner curve? Um, that's a good question. I'm just not sure. We'd have to do a lot of math to be able to answer that. Which I think is what they're supposed to do. I mean, we could do it. Okay, so this has like piqued my curiosity, but if we do a quartic, how are we gonna choose a quartic? Because there's so many different options. Probably we only have one option that can fit the criteria. I mean, let's worry about the problem first. In the absolute value case, we should only have one option, I think. Yeah. So if we just work on a parabola, we know it has a form y equals ax, x minus 1. We can figure out a by using our condition for the integral. 0 to 1 ax, x minus 1 dx equals 0. 0 to 1 ax squared minus ax dx equals 0. 1/3 ax cubed minus 1/2 ax squared equals 0. From 0 to 1. I should have factored out the a at the start, but too late now. 1/3 a minus 1/2 a 0, 0 equals 0. Wait, that's not right. We need a plus k, don't we? No, we don't. What's wrong with this? I'll look at that in a second, Jed. How does this not work? Oh, it doesn't equal 0, it equals 1. Duh. There we go. A third minus a half is a negative 1/6. Multiply each side by -6 to get a equals -6. So with this, y equals -6x, x minus 1. We can use Wolfram Alpha to figure out the area. I can copy paste that, Jed. It's okay. Let me. I want to finish my train of thought here, though. -6x, x minus 1 from x equals 0 to x equal 1. What? Oh, never mind. Oh. 3.249. Let's just go with that. I don't know why the cinch is involved here, but I guess because of the I can see why it might be involved. 3.249? 3.249. That first one is a parabola. So let's compare it with Jed's absolute value. I still don't know how we're gonna do. Oh, that's not where that goes. We still need to figure out a quartic to compare this with. So the arc length of this should be, it peaks at 0.5 and it goes up by 2. 2 squared, 4.1231, okay. So far we're in line then with your, actually wait, no, we didn't have a theory for the arc length. Square root of 17. It's 4 plus, it's the square root of 4 plus, or 2 times 0.5. Oh, that's where you, 16 plus 1, is that what you did? It would be, okay, yeah. Because you can make it a straight line and get the exact same result. So yeah, it's root 17, okay? So we have a trend down. Let's try a quartic though. I guess let's try the quartic that I came up with. I don't know if it's the best one. We can see though. I'm curious, maybe I'm jumping the gun by going to quartic instead of cubic, but who cares? Y equals a, x plus 1, x. I'm just putting in order the roots. This is kind of bad form though. Actually, the more I look at this, the more I hate this, but who cares? We do the same exact process, 0 to 1, a, x, x plus 1, x minus 1. Oh, Wolfram Alpha is going to integrate this for us, and it's going to be great. I'm going to not put the a in, because it's going to confuse Wolfram Alpha. Oh, I could have done that in my head. Never mind. I shouldn't have had to look this up. 1 over 5x to the 5th. Actually, no, I could have done that in my head. No, never mind. Wait, this doesn't work, Jed? Why not? But 1 is 9. Yeah, it is. Oh, yeah. Plus x squared. Evaluated from 0 to 1 equals 1. Okay, plugging things in. I guess the plugging in part is pretty easy. A 1/5. Oh god. Fraction math. Okay, I'm getting everything in 30. Who cares? I'm doing this the way that like kids do it. 15 over 30 minus 10 over 30 plus 1. 6 minus 15 is -9. -9 minus 10 is -19. Plus 30 is +11. A times 11 over 30 equals 1. A equals 30 over 11. Someone's problem? It's a fun problem, Drew. Drew, to me, I waste my time on your problems, and these problems are the fun ones. So it's just a matter of perspective. I think this problem was a fun challenge, honestly. Arc length of y equals 30 over 11, x minus 1, x plus 1, minus 2 from x equals 0 to x equal 1. All right, let's see. 3.3. Is that less than the parabola? No, it's slightly more. Don't tell me ants and rubber ropes are not fun. It's just a harmonic series. It's boring. So it's actually the quartic actually has a higher arc length, which I wouldn't have expected. Now, I might not have chosen the best quartic. There might be a better one out there. And I could have tried to choose a cubic instead. I don't want something more advanced, Drew. I like the level of difficulty that I'm doing. Doing problems that are too hard just isn't fun. I'm sorry. Like I don't enjoy it. Ooh, that's a funky one, Jed. You still need to put a coefficient in front of it. Yeah. Okay. I mean, I don't know if we need to go this deep for the sake of answering this person's problem. Okay, but A equals 6. Um, what does that get us? 3.284? Ooh. Wow, they use inverse hyperbolic tangent. I do not play an instrument. My favorite one, piano is pretty cool. I'd love to be able to play piano if I had a musical bone in my body. Which, actually, I know that Jed can, so I guess you can gloat all you want, Jed. 3.28, it's... My parabola is slightly smaller by 0.04. But it's the second best one that we found for minimizing arc length. Sine? Like, we don't need to do a sine, we're just doing this for fun at this point, but okay. How about you, Shep? Same question to you. So if we're gonna have a sine that opens up my eyes, we need to have, I don't know if we need a coefficient in front. Let's just leave that as is. The period, we need the period to be 2. And if you want a period of 2, you need to Multiply x by pi? We have a sine function of that form? Violins, oh, that's a good pick. Yeah, the square root is a really good, like, non-symmetric one. I'm just going to verify that this sine function is what I think it is. X over pi? No, pi x works. This goes from 0 to 1. Okay. Your fun math questions at my level? we have different interests in math, though, Drew. That's where it goes wrong. But thank you for, like, considering that, but I know we just like studying different parts of math. That's okay. It also sounds enough for making violins. Oh, that's cool. I know that violins can get crazy expensive. So if y equals a sine pi x, let's do our same integration. Dx equals 1 from 0 to 1. Sine integrates to negative cosine. I'm going to put an a out front. And by u sub, we need to divide by pi. From 0 to 1 equals 1. Cosine of pi is negative 1. Times negative 1 over pi is positive 1 over pi. Cosine of 0 is 1 minus negative 1 over pi equals 1. So a 2 over pi is 1. A equals pi over 2. Funny how that works. Very expensive? Oh, yeah. Okay, Jed, we got the same thing. Now let's do an arc length. .36. Me plug it in for myself, but I believe you. .36. The parabola is still the best one. That's 3.249. Does that match with something that their teacher did, though? 3.365? No. The 2.9, we haven't gotten a 2.9. I wonder what that function is. .249 is the parabola. But yeah. Should be include a coefficient. We'll call it a. Multiply it in front of the entire function. Integrate the function with the a constant, or the a coefficient, I'll say. From 0 to 1, and set it equal to 1. Then solve for a, and you will have a function that complies with the third condition. You're going to try and rest? All right, Shep. Sleep well. An oval instead of a parabola. Just the square root of whatever we had, right? Well, I guess, what do we do for the major and minor axes? Or, would it have to be a circle? No, it wouldn't have to be a circle. Would we have two coefficients there, or a coefficient and a constant term? No. The minor axis has to be fixed because the zeros are still 0 and 1. So the major axis you can play with. Assuming it is a major axis, I guess it could be a very thin oval. Or a short oval, if we're talking about the y direction. I'm trying to think about it. Maybe you won't have to worry about so much if you just do a root x times x minus 1. You can just solve for a normally. And not worry about major or minor axes like I was. All right, let's try that one too. I really like like this is probably I've been curious. It's kind of fun to try and just name a function like this. Actually, that's gonna be some difficult integration. It's gonna involve a trig sub. We can let me just do it in Wolfram Alpha. I'm not gonna do it on the board. You gotta do a tangent sub, and that's just gonna be a giant pain. Integrate square root x minus 1. Do they give a non... Oh, it's inverse sine. Yeah, I'm glad I didn't do that by hand. With x equals 1. Indeterminate? You'd have to do the limit. Oh wait, you have to do the limit for both of them. Because either way, the fraction you get 0 in the denominator with 0 and 1 for your integral limits. Actually, not this. Limit as we approach from the... Let's do 0 first. As we approach 0 from the right of this thing. This might be too complex for Wolfram. Actually, I might not have set up the equation for the oval right, now that I think about it. Or maybe be equivalent. I'm just gonna type an answer as person. I think it's gonna be too complex for Wolfram, and it's definitely too complex for me to do by hand. Um, The second one, Jed? Or both of them? Both? Okay. Okay, so you have an equation for an oval here. This isn't the same thing that I got, interestingly. Okay. And then you do the arc length for it. 2.91. 919? 919. Technically, I guess if you round up from the 5, 2.92. 0. You might have just, this might be an oval here for the second example. That's a good call. I wonder if hyperbolas, like what hyperbola would look like. I'm not going to do it, but I wonder. Just found that. Okay. Oh, well, let's solve it for you? It does. Gamma. That's never a good sign. 1.144? Okay. I mean, I'd probably take the estimate, but yeah. uh... 1.144. Second degree to fourth degree? Oh, okay. I didn't even notice that. Really? So you know how to interpret it, but you don't know how to do it, Wolfram? Is that what you're telling me? I don't know how to make it do it. I guess I could manually do the formula with integrals. One plus. We need to derive it though. And do you square this? I don't think you do, right? Do you? You do square it. Okay. I have too many tabs open. See if Wolfram Alpha will handle this. Oh, it just oh my god. It does what I do. It just ignores the hard parts of the problem and solves the easy part. I can't get Wolfram Alpha to do it. Maybe Symbol Lab would. the value get for a into the formula for arc length, 0 to 1, and see what you get out. It should match one of the given examples. A few functions that could be interesting to investigate for this. No, to those gamma functions, they're basically factorials. Like you can calculate the actual number for them. They're like a generalized factorial that works for rational numbers, maybe even like imaginary and weird numbers like that. But basically if you hit the approximate form, it'll give you the actual thing if you calculate out the value of the gamma functions. Parabolas, cubic functions, vertic functions, sine, hyperbolic functions. Absolute value, yeah. Good call. Oval, circles / ovals. I'll do your sphere x, or I'll throw in your like sphere x minus x as well. Do we say anything else, Mike? Or do we say or do anything else? Square root x minus x isn't a circle or an oval though. Or like I meant the square root x minus x one. If I misspoke, I just realized that I might have like said that wrong. Criteria 2, like y equals a square root x minus x. Oh, rational functions. Piecewise functions. Asymmetric one, like the third example. Okay. They probably don't need to investigate all this, but I guess they can pick out whatever they think is interesting, potentially. Probably. I really don't know, though. That was an interesting question to think about. I think we gave them a good starting point. I just like the general technique for how you investigate a function is probably the most important part of what I said. Everything after that is kind of like up to them. Yeah, it gets you thinking. Like the square root x minus x thing was a really kind of neat example that a function that we don't normally study, but still work for the given problem. So I wanted to throw that in there. Limit of 0 to the x as x approaches 0 from the left? 0 to the x would be 0 everywhere with a hole at 0, wouldn't it? Wait, the left side of the graph, f of x equals 0 doesn't exist? Why doesn't 0 to the negative 1? Oh, yeah, that's why 0 to the negative 1 doesn't exist. Never mind. Okay, yeah, okay. Of course, you can't have 0 to a negative power because that means you're dividing by 0. Sorry, my activity feed, I just realized it wasn't updating, but I don't think I missed anything. If anyone did follow in the last hour or two, and I didn't thank you, then I'm sorry that I missed you. I don't think anyone did, though. All right, I've been going for 2.5 hours. Let's maybe look for 1 or 2 more problems. Let's go to Ask Math. Actually, also erase what's on the board. I'll erase it later. This looks too complicated. All right, so L is 1 of the minimum possible value. I see why, because you just consider the straight line on the x-axis. That's where you get that from. Yeah, if you get an L less than 3, you're doing pretty well for yourself. As an answer. Okay, I was gonna skip over this one. We'll just see. I'm okay. I don't know what that's talking about. Um, I'm not finding too much more though. How much money worth is my body weight in weed? I... You got the answer? Ah, no. I put the wrong thing. The area is 1. Why not just do y equals 1? No, this doesn't do f of 0 equals 0. F of 1 equals 0. That's why you can't just do a horizontal line. Otherwise, it would be the right answer. You're right, Jed. But it doesn't meet the first condition. Okay, that's a good point. I don't know how you evaluate it for the sine function, but it's definitely not, or for 1, it's definitely not gonna be 0. I don't think. Oh. Wait. There's no way. Sine of 0 is 0? It's wait, okay. Oh, that's also 0 for 1. Sine function. Gosh darn it, it is defined to be... Oh, it's not continuous. No, they said continuous. That's a discontinuity between 0 to 1. I think that... Well, let's check. I'm pretty sure it said continuous, though. Oh, wait. No, the curves graph below are examples of continuous functions. But the conditions themselves don't say continuous. You win, Jed. If you want, I mean, it's your answer. You can submit it and get the glory, but if not, I will go back and edit mine to include that. I think it kind of breaks the question. You need a link? Okay, yeah. I'm sure it's not intended, like the teacher didn't intend for you to use a function like that. But I guess you win. I mean, you could even just manually do a piecewise function that basically results in the signed function too. SIGN function. I don't know how you're supposed to say it in a different way. You can do a piecewise function just like f of x equals 0 for x equals 0 and x equals 1. And f of x equals 1 otherwise. So you don't have to involve signed function that might get you yelled at or something. I don't know if your teacher's mean. Or professor. What's up with these vectors? This is just a dot product, isn't it? You do the dot product, you set it equal to magnitude A, magnitude B, cosine theta. So you do the inverse cosine of, I should be able to do this in Wolfram alpha, right? So the dot product, multiply the x's by the x's, negative 24 plus 20 is negative 4. Let's do arc cosine of negative 4 divided by something. The magnitude of this one is 9 plus 16 is 25. That's 5 for magnitude. This one, 5. 64 plus 25 is 89, which isn't a perfect square. 5 square root 89. $1.655. Oh wait, they didn't even wait, 4. Oh. There should be a negative sign, but let me see. I didn't realize they didn't have to give an exact result. Let me see. They rationalize the denominators by such a weird number. 4 root 89 over 445. Okay, so we had the same thing. They just forgot the minus sign, I think. Is this a problem though? Oh, dang it. I think their numbers are right. I guess there's... Maybe I'll trust these people, but... I had the same thing, they just got the sign wrong on the dot product. See what this is, Jed? I think Wolfram Alpha doesn't know how to derive the sine function. Especially, or it might be the discontinuity too. To me, the 2 points there have arc length 0. Because they're a single point. In the same way, an integral from 1 to 1 always equals 0. Assuming it's continuous, but... to me, it's still clear that the arc length is 1. But I guess that's just me. There's already 2 answers there, so I'm just going to leave it. Actually, well, no, they're saying the person did... I don't think they're posting out the right... Can Wolfram Alpha just get the angle between the two vectors on its own? Angle between -3, 4 and 8, 5. This person is right. Okay. Just except for the negative sign. Okay. Oh wait. Is that supposed to be the answer? Or is that... No, that's how their answer was interpreted, I think. It wasn't giving them the answer. Okay. This one has no answer. Oh god, it looks really involved though. I don't have the brain power for this. If you do post your response, Jed, I'd be interested to read how you phrased it. More information is given than is needed. Ooh. Oh, they're testing you on whether you need to do it pooled or not? Or paired, rather? Let's do just paired. Because they specifically say same employees for both. Of 16 employees. I'm sure it's not some other test completely besides T, though. They tested the same 16 employees with both systems. They gave a score for each one. That's kind of throwing me off, because I feel like I normally see paired and other very similar, but not quite the same situations. Hmm. I might not comment on that one. Let's see what you put for this. I'll upvote you before I even read it, because I'm just that nice. You care to press your luck, I submit to you this function. That's very polite of you. All right, yeah. I like it. You're back for a second? Well, I was just looking at a stats one, and then also the other question that we were still thinking about. But I think either way, you're not into this, Druha. They either win big with this one, or it gets thrown out entirely. Yeah. I was wondering for a second if it's possible to have a negative arc length or something, so you could get less than one, but it's just not possible. I don't think. Not the way the formula is set up. Yeah, it can't be. We can take it a step further. Oh, okay. Chat? Sure.
This
All
is
right.
just me thinking aloud here. So we've proven you can do one with length 1, right? What happens if we make it half as long and twice as tall? Then L
Oh,
becomes 1/2, but the area under it is still no, because it wouldn't work, because then the negative portion wouldn't be above x. F of x would not be greater than 0 for the entire duration. So we
oh, is
can't
it
do it. It
strictly
can't.
greater?
Huh?
Is it strictly greater or greater than or equal to?
In the original problem, it said that the function had to be positive between 0 and 1. I think that was
The
one of the
actual
requirements.
conditions say greater than or equal to 0.
Right, but if you made it half as short, then where it jumps down to 0, and then after that would jump to a -1. So
Oh,
so if we did it from like between 1/4 and 3/4, it was +2, and otherwise it was -2. So if we did like 2 times the sine of x over 2, or whatever, however you had to do it to make it so it was a half length. But then when it flips down to the negative sign, you'd be less than 0.
so I mean, we don't have to use the sine function though. We could just define our own piecewise function, right?
You could. But what I'm getting at is, you could do a piecewise function that says if x is less than 1,
Like,
0.25 or something like that, or if it's less than 0, it's less than or equal to 0,
I guess
f of x is
strictly.
0.
Yeah.
I wouldn't even do 1/4. I just start at 0, from 0 and less, it's 0. From 0 to n, it's n, right? Or n over 1 over n, I guess is more the
Oh, okay, yeah.
1 over n
And
for
then
x is equal to x is between 0 and n,
and then
not
0
inclusive.
again.
Yeah.
Something
And
like that.
then 0 for x greater than n. Because then if
Okay.
you make n 1/2, then f of x would be 2 for that, for x
But
between 0 and 1/2. So the area would still be 1.
would it be just n rather than 1 over n though if we have one
No,
half?
because you need the area to be 1. So you need the
Yeah.
width to be the
If
height to be the reciprocal of the width to make it 1.
Oh yeah, okay. I flipped the wrong thing there. Okay. I mean, it's just
So
there's
yeah,
a
so that would technically
yeah,
work, and then you can make n as arbitrarily big as you'd want, and the bigger you, or as arbitrarily small as you want, and the
right.
smaller you make n, the shorter L is, but it still
Yes.
satisfies all the requirements.
And so technically if n goes to 0, that'd be like infinitely big. So I mean, you can just choose like the biggest number you want, like Googleplex or something, if you really wanted to do
the
that.
smallest n you want.
Well, it's oh yes, sorry. You
Yeah.
choose n one over like Googleplex, and then
I mean, we could
something like that.
certainly like you could say as n approaches 0.
Yeah.
You know, so but you do have to qualify that for n. 0 is less than x, which is less than n, which is less than 1. You do need to specify the 1 in there as well, because if n is greater than 1, then you don't get the area. You don't get the root basically at 1. So no, at the second line, I just say 0 is less than x, less than n, less than 1. Or less than equal to 1, I guess you could say.
Oh,
No,
yeah,
you
yeah.
can't say equal 1, it has to be less than 1. Because f of
Equal
1
1
has to
does
be
work.
0. Nope.
Oh.
F of 1 has to be 0.
Okay. Oh, you're right. Yeah.
So that's and I mean, we could throw that as a second response. That's like, if piecemeal functions are allowed,
Yeah.
then something like this would work. And the closer n gets to 0, the shorter L. L is equal to n. And so as n approaches 0, L approaches 0. And it
Yeah.
still satisfies all the requirements.
Because we are allowed to use piecewise functions according to that fourth example, even though that one's continuous, but yeah. I like it.
I'll throw that one in there as well.
Okay. I guess that's the optimal solution then. I don't know how you name a better one.
For an even more optimal solution.
Yeah.
Consider a piecewise formula. I'm going to put that response together.
I feel like that there's no way the teacher's going to accept it, but it's still fun. Like, I would submit if I was a student.
Okay. All right, that's all. I'm going to put that together and respond to that as well.
Okay.
Fun times.
That was interesting. Yeah. Thank you. Okay. All right. I mean, I guess we got to the bottom of that question. Because I mean, the teacher should have said it has to be continuous in the actual requirements if that's what they wanted. So technically, it fits all the requirements that were stated. The teacher might have given continuous examples. They didn't say it has to be continuous though. So